Yeah, I've heard that.
All right. Good evening, everyone. Is my voice that bad? Sorry. Good evening. How are you? How's everyone doing? Yeah, thank you guys for coming into the August edition of the AWS Sydney User Group. I'm pretty sure it's going to be a treat for you, for your developers per se. Today's session is going to be on Terraform, and I do expect this session to be pretty interactive. First of all, let us welcome the two awesome speakers. So Russell and Patrick. So Patrick is a solutions engineer from HashiCorp, and Russell is a senior technologist at Amazon. I'm not going to go very deep into this, but yes. So the agenda item looks like such. Russell is going to be talking about Terraform for AWS resources and beyond, and then it'll be followed by running Terraform at scale by Patrick. So without further ado, I will hand over the podium to you, Russell. And just a quick note, I would appreciate if you guys would stick around until the end of the session until we explicitly tell you, dispatch you for the delicious pizzas, as I've got an announcement to make. All right, guys, enjoy the session. Cheers.
Okay. Let me just plug it in.
Push to talk on this one. Okay, hello everyone. So we can get started on this presentation, Terraform for AWS resources and beyond. I'll introduce myself real quick. So I'm Russ, or Russell Sayers. I'm a senior cloud technologist in AWS training and certification. That's a funny title. I've had to explain it going through passport control in an airport. What exactly is a cloud technologist? I'm in the training team, so I write and deliver training content. If you ever go look at the courses that we have on Coursera or edX, that's exactly what I work on. That's also what I present. I have a little bit of a slide here, just talking about what it is I've done in the past. So most of my career has been a software engineer here in Sydney. The last 5+ years, I made the move over to tech education. I spent some time as a technical trainer, so I traveled around teaching some AWS courses, and then I went more behind the scenes. I worked on some repositories that we have in training and some continuous integration pipelines that go off and create training material and send off like lab content to labs. So if you've ever sat through AWS training, some of my code is in the pipelines that go and build all of that. Most of my career has been .NET. I think .NET's kind of a popular topic in Sydney. Is anyone, show of hands, how many people are doing .NET kind of work? Yeah, sometimes I don't admit to it. I think it came out of the banks here in Sydney. I worked for Combank at some time, and a lot of the tech there was .NET. I made the change over to Objective-C when I worked at Amazon. I was a software engineer at Amazon, working on the mobile shopping app. So that was before Swift came out. So I was an iOS developer for a short time. And then over in the training world, there's a lot of Python and lots of building cloud infrastructure. I noticed a lot of sample applications now are in Python, and a lot of machine learning stuff is now in Python. There's my Stack Overflow profile. There's not a lot of activity on there recently. I probably do a lot more copying rather than pasting on Stack Overflow these days. But if you write code, you know that website. Down the bottom is some certifications that I've done recently. I wrote a course on Kubernetes, so I went and sat down and did the actual CKA, CKAD certs. And because I work in training and certification, I'm sort of expected to go and stay up to date on a lot of AWS certifications too. But that's probably enough about me. Today we're going to talk about AWS infrastructure and how we can provision that infrastructure with Terraform. So a quick show of hands, who here has a job where they create AWS infrastructure? Yep, okay. And probably the other side of that question is how many people have a job where they write code? Yeah, okay. Who does both? Who works on code and infrastructure? Yeah, kind of full stack kind of work. I like to ask those questions because I just, over in the training side, things can get a bit academic, and I'm interested to know how people work, who's writing code, who's creating infrastructure, and the whole DevOps kind of approach to things. So I asked the question, what's your level of familiarity with AWS? This is an AWS meetup, so I'm going to say most people are pretty familiar with AWS, good. And a show of hands, how many people are familiar with Terraform? Okay, that's most people. I guess because we're talking about infrastructure, Terraform is the tool that we go from a declarative format to infrastructure. It's certainly in the kind of DevOps arena. There's probably people here who have DevOps in their title or site reliability engineer, those kind of titles. Okay, so Terraform is a tool that we use to automate the provisioning of infrastructure. To run an application on EC2, well, to run an application on AWS, I'm turning on a lot of infrastructure. I'm turning on EC2 instances, I'm creating VPCs, I'm creating security groups. There are some very good reasons to automate that provisioning of infrastructure. The number one reason I would say is codification of knowledge. I will admit, in roles in the past, I've gone into the console and just thought, okay, I'll create this EC2 instance, I'll put it in this security group, or put it in this VPC, maybe I need to put another subnet on there. If I'm clicking around and doing that manually in the console, I'm never going to remember what I created. I think if I come back and look at that in 2 months, I'll be wondering, why did I turn on that RDS database? Am I even using it? Generally when the bill comes is when I'm going to go and look and try and work out why I created all those things. We're provisioning things automatically for scale. Some of these DevOps type teams or SRE teams are relatively small teams who are maintaining hundreds of pieces of infrastructure, thousands or hundreds of EC2 instances. So the amount of work that a small team can do is going to be much, much better when we're provisioning things automatically using a tool like Terraform or CloudFormation. And also anything that we're doing manually is going to introduce human error. I can share a story of my own human error. One of the very first things I did in the training team is we had to go and create S3 buckets in every region where we deliver our labs. So that was 10 different regions at the time. This is actually a coworker who sat in the console and thought, okay, I can see here creating 10 buckets in 10 different regions. Of course, they named one of the buckets wrong, which broke a whole bunch of labs in one particular region. My answer to that was, we have the AWS command line, let's just write a bash script and do it automatically. That's going to reduce the potential for human error in there. So here is where I introduce Terraform. Terraform is how we can treat our infrastructure as code. I'm followed by Patrick from HashiCorp, so I'll admit that I'm not a total expert on Terraform, but I'm just going to give an introductory look at what we use Terraform here. I did see a lot of hands at the beginning of people who already know what Terraform is, so I can probably talk a little bit faster here. We use Terraform for infrastructure as code. I write a file that describes my infrastructure. I hand that on to Terraform, and Terraform is going to call APIs to go and create that infrastructure for me. I'm an expert on AWS, so I'm going off and creating AWS infrastructure. We say it's a declarative language. Have people heard that term before? Declarative. Declarative versus imperative. Declarative means I'm defining the state that I want the infrastructure to be in. SQL is a declarative language. SQL, I'm not saying how to go and get things from a table. I'm just saying select star from this particular table. I'm defining the desired state. And we're doing the same thing with Terraform. I want a VPC, I want an EC2 instance, I want some security groups. I'm writing that into a declarative file. I'm not saying how to do it. Terraform is smart enough to look at that file, look at the dependencies within that file, and then talk to an API to create all those resources in the create sequence. Terraform uses a provider model. Terraform wants to go and talk to APIs to create things. There are many, many different providers out there that can go and talk to different APIs. There's a Docker provider, there's other clouds. I know that AWS, there might be more clouds than just AWS. So you can even go and create resources in those other clouds out there. I will show an example of this. I have a demo at the end of this where I'm going to go off and turn on an EC2 instance with an SSL enabled Nginx server on there. So just think now of what the steps are that you would go through to do that. We're going to do exactly that in Terraform. So inside a Terraform file, I'm defining some resources. Is this going to work? There it is. I'm defining some resources. So I'm saying, go off and create me a VPC and all the parameters that we need to know to create a VPC. What's my CIDR range? Do I want to enable DNS? What are the tags that I want on that particular resource? That's what I hand on to Terraform. Terraform's going to call some AWS APIs and create those resources for me. Not only does it create resources, it's going to update resources as well. This is a good reason to treat our infrastructure as code. If it's code, I can put it into source control, I can turn on some continuous integration pipelines, and when it's time to make changes to my infrastructure, what am I doing? I'm changing the code, committing to source control, and maybe having Jenkins or code build or something go off and deploy that for me. This is the general workflow that we go through when we're using Terraform. The first command there, terraform init, will initialize things. I said it's a provider model. Terraform init will actually go and download those providers. I think they're Go binaries that it will pull. There we go. I got a nod from HashiCorp. It will pull down those binaries into the directory where you're working. Terraform plan will generate an execution plan. It's comparing the observed state to the desired state. So let's say I want to go and enable an additional port on my security groups. I'm going to go and change the Terraform file. I hand that on to Terraform and say, plan this for me. it's actually comparing what it observes in AWS and what is in the state store. We'll come to that. And that's how it's coming up with a plan to say, okay, I see what's changed. You just need to add an additional rule to your security group, and it goes off and creates that for me. The very last command there, Terraform apply, is what will actually go and make the changes. So it's nice to be able to plan first, see exactly what it's going to change, and then call Terraform apply to actually make the changes. There is a concept of state in Terraform. This is what maps config to the real world. We're going off and talking to APIs and creating things. In the example that I'm about to show you, I go off and create an SSL certificate. That needs to be remembered somewhere. That's also used as a comparison for the plan to know what has changed. So it's storing metadata, information about the resources. I saw in the HashiCorp documentation, there was some debate of whether this could be stored in tags, but then there's eventual consistency problems. So it's sort of being stored redundantly in two places. It's both in your cloud and in the state, and then reconciled when we perform a plan. I saw another nod there. Thank you, Patrick. There are multiple different state backends, and I think we'll get into that in the next presentation. By default, state will be stored as a file on your laptop, but that's all interchangeable. So we can go and store our state in S3, remote, which is the cloud product from Terraform, console, GCS, Postgres as well there. It's important to know that you can encrypt secrets. I just gave that example of creating an SSL certificate. When you create an SSL certificate, there is a private key in there. We want to keep private things private, so I don't sleep too well if that particular certificate is being written somewhere unencrypted. In this example, it will be unencrypted on my laptop. In production, there's some good documentation on the HashiCorp site about how I could store that in S3 encrypted. Inside our Terraform files, we also have a concept of a data source. This is how we can use information that's defined outside of Terraform. The example that I'm giving here is AWS AMI data source. I give it a name, Nginx demo, and the parameters that I'm passing it is saying I would like the most recent AMI owned by Amazon, and I would like to filter on this value. I'm looking for the Amazon Linux 2 AMI, the most recent edition of that. Actually, I recognize that API call. It's going to go off to EC2 describe images and find the most recent AMI. I don't want to hard code AMI IDs into my templates, so I use a data source to go off and retrieve that. There's another example of this later on, that when I want to go and retrieve an IAM policy, I'm also using a data source for that. Okay, we can also, inside our Terraform templates, have variables. I've written a template where I pass in the region so that I can run exactly the same template in different regions and create resources that are kind of namespaced with the region for global resources, or put into a different region. There's an example of a reference here. An instance profile has a reference to a role, and my EC2 instance down here has a reference to that data source that we saw earlier. Data.awsami is going to contain the most recent Amazon Linux 2 AMI. And it's through these dependencies that Terraform knows the correct order to go off and create things. So this particular instance belongs to is launched into a subnet and uses this security group. It means that that subnet and that security group needs to be created before the instance. And Terraform's smart enough to understand that hierarchy of dependencies and create things in the correct order. I might actually pause here and just make sure, is there any questions at this point? Is everything kind of making sense so far? Yep. Okay, a few nods. We're getting to the end of the slides, and then I'll switch it over to my laptop and give a demo there. I like this quote from the HashiCorp documentation. Terraform uses a single core engine to read infrastructure as code configurations and determine the relationships between resources, then uses many provider plugins to create, modify, and destroy resources on the infrastructure providers. The example I'm about to show you has 2 providers. I'm going to trip off to Let's Encrypt to get a certificate, and I'm going to trip off to AWS to go and turn on infrastructure. Okay, this is where I switch over to the demo, but just think about it. Feel free to yell out an answer. If I just want to turn on an instance that has SSL or TLS enabled, what kind of things do I need to create?
VPC, subnet, AC, security groups, AC to, if you want to use, or automatic baseline engineering, then you have to define the user data to run shell script.
Okay, very good answer. I actually initially did this in user data, and I switched it over to a run command, and I'll show you why when we get to the end of the demo. User data runs on first boot. I actually want it to run anytime the values change. Yeah. Okay, so there's quite a few things that we need to be able to turn on an SSL-enabled Nginx box. I need an IP address. I need to register a Route 53 domain. I need to go and create a certificate, and the common name on that certificate up here needs to match the Route 53 entry that I just created. Okay, so let's switch it over to the laptop. Okay. So you should be seeing what's on my laptop now. Okay, good. I ran this demo so many times today. Has anyone ever used Let's, is there a question there? Make it bigger? Sure thing. How's that? It's like an eye test. Can you read the top line? I'm overdue for my classes section. If I go any bigger, that might...
that's good.
Okay. No problem. So I ran through this test a few times today. How many people have used Let's Encrypt? A few. How many people know what the quota for Let's Encrypt is? They will restrict the number of certificates you can make. It's 50 certificates per domain per week. And I've tested stuff enough that I blow up my quota. The fix for that was to go and register a different domain name. I think my quota has reset. If it goes wrong at this point, I have a backup domain name. So hopefully I've tested this enough times.
Use the staging Acme server.
Oh, there's the staging Acme server. And are those certificates recognized by the CAs?
No, but it lets you do a lot of testing without busting your quota.
Right. Yeah. And is there a CA I can import to use the staging one?
You would just get an error saying it's not trusted.
It's like a self-sign.
Yeah.
Okay, right. Thanks for the tip. I didn't have to spend $10 on another domain today if I hadn't known that.
Getting expensive.
Yeah. Let's go through the resources I'm creating. I'm creating a TLS private key, and I'm referring to it down here in the Acme resource. That's actually how you authenticate to Let's Encrypt. If you haven't used Let's Encrypt before, it's a product from, who creates Let's Encrypt? It's one of the privacy groups. Someone or other, the Electric Frontiers, EFF, yeah. It's a product from the EFF that anyone can go off and create a certificate for free using the protocol Acme. Some other certificate providers now actually use this protocol as well. And it's a way that I can just turn to Let's Encrypt and say, can I have a certificate please? I've verified that I own that domain, and then it will respond back with the private portion, the private key of the certificate, and the actual certificate, and the there's actually a chain of certificates that are served up when you connect over TLS. So the next resource I create here is an Acme registration. and then I create an Acme certificate. And I'm referring to the account key that I used to authenticate to Acme, and a common name on that certificate. That is actually stored in my variables over here. So I've configured a variable for what region I want this stuff created in. I refer to that region here. I'm actually going to, because DNS gets cached, I'm going to change that to region-demo.beta-seattle is the domain I bought recently, and the Route 53 zone of where it's going to go off and create that A record with my IP address in it. The configuration here is DNS challenge. You have to prove that you own that domain. This is a feature of Let's Encrypt. The way that, there's more than one way to prove it actually, but one way to do it is to go and create a temporary record in your DNS zone, a text record, to prove that only you could have possibly created that text record. It proves that you own the domain. So I can't go and create a certificate for a company that I don't own. I plan to store this in an S3 bucket, so I create a KMS key to encrypt it. I create a role for my EC2 instance. See, this is a data type. This is a reference to a policy that I'm going to use. This is the assume on the policy. EC2 roles, you need to say which service is going to assume that role. I attached the SSM managed instance core on there. That's a feature of EC2. We changed the name of this service. It is called, I'll think of it later. I have it open in Firefox. There's some operations that I want to do on that EC2 instance that's going to use the agent on there. So I need to attach a policy to allow that. And I create an IAM role. There's a reference to the policy that I need, the assume role. And I put another policy on there to allow it to use that KMS key. I'm going to put something in an S3 bucket, encrypted with a KMS key. So the role on the instance is going to pull that certificate down, and it needs permission to use that key to decrypt it. So I'm allowing a get object, list object, and here is that interpolation syntax, the $ curly brace. That's a reference to a bucket that I've created, both the bucket and the objects within that bucket. Here's the bucket I created, and now this is kind of cool. Now that I have a bucket, I can actually go and create objects in the bucket. That's a type of infrastructure, it's a resource. Terraform understands S3 objects, and the content of that object is going to be the private key portion of the certificate. So at this point, I've tripped off to Let's Encrypt. I've said give me a certificate, and I'm going to store in the bucket. There's 3 portions to it. There's the private key, the certificate, and the issuer certificate. That's just created the certificate for me. And if I look over in the instance, we see again the data source to go and look up an AMI for me. In Route 53, I'm finding the zone where I plan to store my A record. And this is, right, and I create an instance profile. This is how I associate that role with the EC2 instance. Now my code running on that EC2 instance has the privilege of that role. That's what allows my code to go and retrieve the certificate from S3 and decrypt. And this is, we talked about user data earlier over there. This is the alternative to user data. An SSM document is going to perform a run command on my instance. This is how I run a tiny bit of code on my instance to go and grab that certificate and configure Nginx for me. So here's where I install Nginx. Here is references to those objects that I just created in S3. There's the certificate, the issuer, and the private key. I'm putting them in places where Nginx expects them. And then I configure Nginx to serve on port 443, and there's references to that SSL certificate I just created. Did I see a hand up? Yeah.
Just quickly, so you referenced a tag to your local zone, so I assume Terraform could have done the creation of that as well. You've just created that before, is that correct?
Yes, correct. So I already have a zone configured in Route 53.
Yeah, but if I want to do everything from scratch, obviously
You sure could, yeah. Yeah. Question?
Why didn't you just use certificate manager, just so you could have two providers in Terraform? Is that the only reason?
To be able to show, this is something I've used in the real world. Certificate manager, I can put certificates on a load balancer and a CloudFormation distribution. Certificate manager won't easily export the private key for you to put onto an instance. So yeah, there is a way to do it through enclaves, but certificate manager, when it originally first came out, wouldn't give you the private portion of the key, so you couldn't configure it on an instance. Now you can.
Right.
If you look at Nitro enclaves, there's a way to do it. Is there any more questions? This is a good point to pause. Is any more questions, or it's all making perfect sense? Okay, good. And then I enable Nginx and I restart it. Let's actually kick it off. Down here in the terminal window, I need 2 hands to type. Give me 1 sec. I'm doing the Terraform init command there, which is going to pull down those provider binaries so that I can do things like TLS, Acme is the protocol to retrieve the certificate, and AWS. Okay, that is done. So now I can do a Terraform plan. And because this is all brand new, it's going to show me all the different resources that this is going to create. It's going off and querying AWS to find out what's created. There is no state at this point, so every single thing there on the list is going to get created. I'm going to Terraform apply. And we'll start seeing that. There we go. It's doing that same query to see what hasn't been created. I'm going to allow that to create, and we'll see some things starting to get created. It's actually creating things in parallel as well, like CloudFormation, because it understands the sequence of dependencies. There are things that can be created in parallel. So I can see my Acme registration, my KMS key, the VPC, the bucket. There's a lot of things getting created there. So that's going to take a little bit of time, so we can kind of watch along and we can answer any questions. Is there any questions at this point?
The really
Yeah.
basic one, so you just mentioned it's creating CloudFormation, so it creates the CloudFormation templates and then...
If I said that, I said the wrong thing. CloudFormation's not involved here.
Like CloudFormation.
CloudFront. It's just this CloudFront.
Yeah, I'm also not using CloudFront either. I do get those two mixed up. But so CloudFormation is not being used here. It serves a very similar purpose. So I have a slide coming up on CloudFormation. CloudFormation is also a place where I create a declarative file, hand it onto a service, and it will go and provision infrastructure for me. Yeah. Yeah. Question.
You had like some restart commands or something like that in the Terraform, and
Yeah.
Isn't that kind of like imperative or procedural stuff inside of the declarative declaration?
It is. So I could have used something like Ansible there to have a declarative file. Like, if you've heard of GitOps, people follow these GitOps practices that prefers imperative over declarative. The assumption with imperative is someone's written a tool that's going to do a better job of it. If that script failed halfway through, I haven't written the script to accommodate that. So yeah, I could have used Chef or Ansible or something on there. There is actually SSM documents from AWS that would do that. Yeah. Hey, it's finished. What are the chances this will actually work when I click that link? Let's give it a go. DNS can get cached. It's just. Do I have a term?
You change the DNS name to Devo Live link or something like that.
Yeah. Hey, if I curl it, it works. Hey, let's try that in a new tab.
Private.
Hey, of course it worked. Of course I knew all along that was going to I'm probably over for time, so let's quickly wrap up on this. There we go. So we saw how Terraform can talk to two different APIs and how it neatly integrates with that. How I could go off and create a certificate and put it into an S3 bucket. I think that's kind of cool. Because of who I work for, I should mention some other services. AWS CloudFormation is, like I said, lives in kind of the same part of your toolbox. CloudFormation is also a place that I give it a declarative file, and it will go off and create things for me. There is also the concept of custom resources. We can write Lambda functions inside of CloudFormation to go and create things that CloudFormation doesn't know about. If I were to re-implement this in CloudFormation, I would use a custom resource to go and do that trip to create the certificate for me. And what a lot of people are now using is CDK, the Cloud Developer Kit. That is an abstraction on top of CloudFormation that lets you write code in TypeScript, JavaScript, Python, Java, C#, .NET, and Go. You create constructs in there using code, and constructs refer to each other just like a CloudFormation template does. It will go off and create a CloudFormation stack for you, but these constructs are very smart. There's level 1 constructs that are just an exact mapping to what CloudFormation does. There are level 2 that are a higher level of abstraction. There is a VPC that's actually going to go off and create multiple things, and it has parameters into it to say, I don't want to use a NAT instance, I want to use a NAT gateway, that kind of thing. So people are developing constructs for CDK. It's very convenient for code reuse. Within an organization, we might have one particular way that we like to create VPCs, so we'll create a construct to do that. A level 3 construct is a very opinionated construct. It's a pattern to do a common task. So there's one out there to create an application load balance Fargate service. Just with 3 lines of code, it will go off and create all of the Elastic Container Service resources, and you point it at a single Docker Hub image or something like that, and it will create all the resources to host it. So level 3 is at a much higher level up the stack. Okay, and that's where I wrap it up. Thank you all.
I was just going to mention that Terraform also has modules, which is the library
Yes.
Terraform.
Yeah.
And it also supports iteration, where CloudFormation doesn't natively until you go there.
Correct.
And also, my question is, why wouldn't you just use A or B? Why would you even use Nginx? Just
Well,
wasted your time.
Depends who's paying the bill. This all launched into my own personal account, so I'm paying for it. But sure, yeah, an A or B can terminate SSL for you, sure.
And A or B is going to be cheaper than that.
I would have to cost that out. I would still need an instance running.
No.
Let's talk at drinks. We can cost that out.
We'll just leave the questions to the end of the session, so we'll get Patrick to present, and after that, we'll just get the questions. Ask them the questions personally. Thanks, guys. Patrick, podium is yours, man.
We out of seats.
Hello. Hello, it's me. I didn't realize there'd be so many people here. It's amazing. This is by far the biggest crowd of people I've had willingly listen to me. So thanks for looking the doors, Annie. I appreciate that. So here to talk about running Terraform at scale, and thanks so much to Russ for that introduction. That was really good. How many people here are actually using Terraform today? It's a lot. Okay, cool. And was there anyone who say that they're running it at scale or looking to run it at scale? Yep. Okay, we've got a few hands. Cool. All right, so let's see how we can explore that a little bit further. So, my name's not Zach Law, so this is the first thing that's wrong with my slide deck. And it's only going to get better and more interesting as we get into my demo. My name's actually Patrick Carey. Zach couldn't make it today, so I'm just his talking head, speaking through me. So the key themes I want to cover today, and we've got a fair bit to get through. I'll see when I'm supposed to finish. Workflow and code structure, managing state, controlling execution, governance, and people and skills. So I'm going to break this out into kind of two sections. The first section, we're going to focus on these themes in the first section, and that is, if I started running Terraform today, I saw Russ's awesome talk, and I was going to go home and check it out. How would I go from there to collaborating with my peers and my colleagues, and how we could work together to build something that would scale? And then in the second half, it's a game in two halves, we're going to talk about some of the examples where I've seen customers who have taken that step and they've hit scale problems there as well. And so we're going to talk about what happens once you scale Terraform and what challenges to look at that scale. So typically we see customers on this journey when they're working with Terraform, mostly businesses. And so we're going through adopt, standardize, and scale. Typically, you may be more familiar with crawl, walk, and run, but we start here in the adopt phase where we start to figure things out. We might be working with AWS, single cloud. We're figuring out how to deploy multiple things in parallel and have that working for us. Then we need to start standardizing that. So how do we share that? How do we collaborate? How do we make sure that what I'm doing, someone else can benefit from without having to be an expert as well? And then we get to the running stage where everyone wants to do it all the time, and we try not to trip over and do it in an efficient manner where not everyone needs to be an expert and may not even know that they're benefiting from the code that other people have written. Typically around the standardizing scale, we talk about the modules as well and start to look at, is there other things that we can automate outside of public cloud? So Acme was a really great example of one, but there might be something else that you guys are using that you want to automate, like VMware or PagerDuty or Spotify, important stuff. So starting out with Terraform, very much like Russ did. So you start on your Apple IIc. If anyone has put your hand up if you've written Terraform on an Apple IIc. Still no one? All right, cool. We'll get there one day. You probably don't get all those colors actually on an Apple IIc. But we start writing our code, and we're going to run a Terraform apply and pretty much stand up exactly what Russ had. We're going to have our web server application with our security groups, VPCs, storage backends, all of that good stuff. And then we get to the problem of, all right, this is really cool, and I've just automated a really important part of my job. Now, if I can do this more, and I can get my colleague to do it, then we both have more time to play Starfield. So, how do we keep getting this working across our team, and how do we encourage those people to start learning these new skills and collaborate and build on top of each other the building blocks that we're building here? Multiple contributors, need to make it easy for your users. The people writing the code may not be the consumers, so how do we get them enabled to benefit from this? How do we do governance? What does good look like? Does everything need to happen on my laptop? It doesn't sound like it's going to scale super well because I'm running on an Apple IIc. And how do I manage that state? So there are two main areas of control. And this is where best practice really starts but scaling really starts with what does my code look like, and what are the frameworks and the governance around that? So I saw a bunch of hands. Most people put their hands up when they said, Russ asked if anyone's coding. So you've got workflows that you need to follow, governance patterns, role-based access control around who can commit to what, You don't trust any managers as a general rule of thumb. But we need to start having those same kinds of principles for our infrastructure as code, because without those sort of controls and governance, we're never going to be able to share our code and have our colleagues benefit from that. So we need to have testing frameworks in place. We need to have policies about who can commit, what's our branching methodology, you know, what does good look like? When can I start sharing my code? So I can spin up my Nginx with SSL front ends, but how do I know that someone else is going to be able to use that? You know, are they going to start issuing certificates on my domain and break my SSL that I've already deployed? So what does that governance look like, and how do we build those best practices and those controls around managing our infrastructure as code in VCS? And the second one is execution. How do we scale out Apple IICs to run all the Terraform? And so the answer is we're at Cloud MeetUp today. So let's start to use the cloud to scale that out, right? Much as containerization does have a ephemeral place to run all of our execution that's going to be consistent every single time and ensure that we get the repeatability that we're writing the code for. So much as, anyone here familiar with like 12-factor apps? Yeah, a couple of hands. So yeah, basic principles here, you know, we want to separate our code and configuration variables out of our code so that we can reuse it. And our environments change and our use cases change, we need those variables to adapt. If we're going to split out our Terraform code into its own repository, what are the rules of that repository going to look like? Are we going to have one Terraform repository for everyone to collaborate on? Is it going to be on the same branch in the same subdirectory? Or are we going to have a Terraform repository for each application or each project or business unit that's operating in the enterprise? Both have their pros and cons. Google uses a monorepo. If you guys think you're Google scale, that might be the approach. Other people are using many repos. We touched briefly on modules. Modules give us reusability. I don't know the CloudFormation term for it, which might be more useful as a comparison. But there's typically 3 tiers of modules as we scale out. The first example is if you want to stand up an EKS instance, you might go to the documentation and figure out all the variables that you need to work with the AWS API and deploy EKS. Alternatively, you may go to the Terraform registry and find the EKS module that AWS has written for you and say, I'll just use that. Awesome. That's the first one where people start to scale. And then we move on from the adopt phase to the standardized phase we talked about earlier. And you'll take that AWS EKS module and you'll say, how do I make this specific for like my environment or my business or my team? And how do I make sure that we get the consistent deployment that we need each time so that we've got the governance, we've got the right instance profiles, roles attached, CIDR ranges. And that gives you a tier 2 module where it's specific for your business or your use case. That allows you to share your code a lot more easy because anyone in the business who wants EC2 now can use the code that I've written from that module. Then we get to the tier 3 case, which is EKS is still a building block. And if I take the module that's been customized for my business, I've got a building block that's custom for my business. But if I'm using that 100 times a week to deploy my LLM module, Jupyter Notebooks, with the same backend, storage backend, why don't I make a module that uses all of those components that I need in the same setup, and I can just run that 100 times a week and always get the same result? And then I can share my actual business use case or my actual application project as a module to colleagues in my team. So they're no longer deploying building blocks, they're now deploying a whole unit of whatever I'm working on that's repeatable. I mean, development workflow, tests and merge best practices, PRs, all of that good stuff. Really build a culture of sharing code. I know a lot of developers and a lot of people work as a team, but kind of in isolation. But when we're building IAC, we're really building blocks that are reusable. And the more we share them, and define, we've got our coding practices and we define how we share them. What does good look like? What does the documentation to use my code look like? Am I going to build an image, video to show people how to use it? You know, or are we going to call it through a chatbot and have it deployed that way? But make it easy for your people to use your code so that everyone can benefit from that. And don't store your secrets in code. It's a pretty simple one, but can anyone tell me here if they have not accidentally put their like EC2 or their AWS client ID in Git? Has everyone done it? The pre-commit hook? But that does have you fix the problem, but is the pre-commit hook there because someone did it? It's pretty easy to do. So yeah, it happens, but start to think about as you scale out, what's your process? Is it pre-commit hooks? Are you going to use a password manager? Are you going to use some other JWT, I don't know, way to authenticate, but build those practices out. The second phase is execution, right? Terraform, like as you get started, applies on your laptop. HashiCorp has built out Terraform Cloud. It's freely available online to get started as a way to make this easy for you to get started and just consume and share. So it gives you a control point to execute all your Terraform, a way to securely store your variables. Your state will be stored in a secure location, encrypted for you without having to think about it. You get to store secrets securely in sensitive material, and you can share out those, not only just your code, but you can share where you run that code. So someone doesn't even need to know how to write Terraform, and they can go into the Terraform Cloud and click run this for me, and they'll get the results that they need. So it gives you a controlled way to do that. You get to keep your logs around there. Your logs will live forever, which they don't if you're running it on your bash profile, or your bash terminal, sorry. And you can also enforce governance through there, through using tools such as Sentinel or OPA if you need to, which means if you don't understand what's happening with Terraform and you accidentally make a mistake, we can catch that and enforce best practice, or enforce not making silly mistakes. This is the kind of the workflow that Terraform Cloud looks like and allows you to scale that out. All of those challenges we talked about around execution and building some coding practices in, this will adapt to that, encourage you to use those coding best practices, running from a branch, running from subfolders, making it accessible to people but restricting them, their ability to execute, and applying governance and policy over the top. So Terraform Cloud allows you to go from the adopt to the standardized phase. But what happens when you adopt Terraform Cloud and then you scale to the next level? And what are some of the challenges that will fall there? Typically we have what's called a workspace, which is a one-to-one mapping between a Terraform state file and a Terraform repository. It also allows us to securely store secrets, such as cloud credentials or anything else that we might need to, like private keys, in that workspace. It's everything I need to run Terraform in one spot. This is really good. Once you build out your first Terraform repo, you can map it up to a workspace, no problem at all. But what happens is, because we're using building blocks, eventually your Terraform workspace gets really, really enormous. And you're scaling out across the business. Your team no longer uses Terraform, but the database team also wants to use it, and so does the network team. And each of these teams has different responsibilities. So how do we separate that out and give segregation and control to the different teams? Well, we can all collaborate together and make sure that our network policies across the entire cloud landscape are going to be consistent, regardless of what the database team is doing, and we don't need to step on each other's toes. One approach to this is to give these different responsibilities to run a workspace. And that allows everyone to work in cohesion without stepping on toes and collaborate together. The database team can make changes without anyone else having to be involved. What happens here is we need to start grouping these together. We now have a feature called projects, which is an abstraction layer above workspaces and allows us to more flexibly control our role-based access control. But what I've seen in the past is some teams have been really scaling out quite quite heavily across the business. And one example I remember seeing was someone had decided that all of their DNS entries would go into one workspace. And this was really good. It gave them a standardized approach to scale with, where the network, to whoever needed access to that DNS zone file could make changes. But when they got to about 20,000 DNS records in one workspace, they realized that things started to get a bit slow when they wanted to make minor changes. And they started getting retries from the cloud provider's API, where it said you're running in parallel and you've done 10,000 requests in the last few minutes. Slow down. So it's a really good example of scaling out to different degrees. You need to start thinking about that separation of control. VCS connection, doing things like pull requests and merge requests and testing if your Terraform is going to break before running it is a really, really great feature that you can sort of implement, because testing is good, and when you're deploying to production, you want to make sure that you're not going to break anything. A private registry to share your modules across your team. So when you get started with Terraform, pull your modules from the public registry, but you need a mechanism to find the ones that you're sharing across your entities. Sensitive variable storage and governance as well. Is anyone here familiar with OPA? Open Policy Agent? Some hands? It's a governance framework to ensure that people aren't making silly mistakes, such as opening up firewalls to the internet or Port 22 and controlling what's being deployed into clouds. When you start scaling out through infrastructure as code, you're giving a lot of people a lot of ability to provision very quickly and at scale. And you typically need to put some guardrails in place, whether they be guardrails in your public cloud provider to ensure that bit mining boxes and Minecraft servers aren't popping up on the weekends in the government account. And so applying your governance before things are deployed gives you a mechanism to stop that spend before it actually hits the cloud. So you can put rules in place to make sure that the 4x large server doesn't go out and start costing you, and then you've got to destroy it. Sorry. And Open Policy Agent is one mechanism to do that. I'm going to give a quick demo if I've got some time left. Annie, what time's supposed to finish? I can give a quick demo. All right. All right. So, and you said the pizzas aren't here, so I've got to talk for another 40 minutes. So, this is so interesting. I typically do these things on web conferences, but I can actually see I'm boring everyone in real time without cameras being turned off. So this is quite a cool experience. So making fun of myself. All right. So you'll see what I've got here is I've got a number of workspaces, and within each workspace I've stored my variables. I've mapped that to a GitHub repository where I've stored my Terraform code, and each workspace is independent of each other. These are the workspaces that I can see with my role-based access control. And on the left-hand side, they're grouped into different projects. I don't know what an Azure is, but I think it's blue. So I've got a workspace here called HashiCat AWS Dev. And you can see it was last successfully applied. That was the last time anyone did Terraform run, and it worked. So that's cool. Not my code, obviously, but I was going somewhere with that. What we can see here as well is I've got a health warning. So I'm going to click into this workspace, and this is Terraform Cloud. So this is how we're going to, the first step onto scaling Terraform and collaborating is to adopting a centralized platform where all my Terraform runs can be done, collate all my logs, I can do my policy, securely manage secrets, and everyone has access if they need to. So within this project, within this workspace, I can see based on my GitHub account, did I last triggered a run 3 hours ago through the GUI, and this was the git commit for the code that I ran. We can see about my governance policies, how many passed and how many failed, if there was a cost for this, how long it took, and what happened. So in the last particular run, I added a resource, 2 were changed, and 1 was destroyed. And then down the bottom here, I have a collection of all of the a list of all the resources that I've deployed, and typically any outputs that I might have defined from my Terraform code. Every time, as a gentleman over here pointed out earlier, if you want to deploy a web server, you need a whole bunch of building blocks in AWS. But as a user, I may not always care about that. What I want is actually just my URL for the web server that I've deployed. So just making the information and surfacing that to the users to make it easy for them to consume. So I can see my cat app. There we go, welcome to my cat app. I hope you like cats. What I'm going to do is I'm going to have a look at this run. And I can see, much as Russ showed earlier, we have a plan, a Terraform init, a Terraform plan, and then an apply. So I get my information, which links out to my repository. We can see in the UI, it's going to show me just the meaningful information. Because this was a second run, I didn't deploy everything because that takes a bit too long, but we can see what needs to be changed and very quickly get an overview of what might happen in my AWS account. I can get a cost estimation before I deploy anything. Based on this plan, what's the monthly cost going to be and what's the change in cost? If I'm not deploying from 0, if I'm deploying 50% increase, maybe I'm increasing my EC2 instance, what's that going to look like on my bill at the end of the month? How much is that change going to cost me? Get the delta. Once we've done that, we can see the governance policies here. So this allows us to really scale and put guardrails on any changes that we're going to be pushing through Terraform. So I can see here I've got a description of a policy that's applied, which is said restricts the modules that people can deploy. So someone might go out and get a module from the internet, and my business might not want that. They might say we only want modules published by AWS to be used. Don't let anyone get those dirty Azure ones. We're going to block it, right? Or we're going to put an alert or a warning or something like that. Typically the case here. And we can be pretty flexible with this, but typically we're just going to enforce mandatory tags, make sure that everything is tagged because as part of good governance, or we might want to restrict on the size of the EC2 instances that are deployed, and this allows me to block anything before it's actually deployed. And then finally, I'm going to get my apply. Now, there are 2 ways that I can make changes to this. I can typically go into my variables where I've securely stored my access keys and secret keys, and I can actually change my instance size here, or I can change it in my code if I need to as well. One of the things that's really interesting is if anyone here is using AWS, how long are your resources typically deployed for? If you deploy something into AWS, are you guys deploying in a dev environment for an hour or a day? And if you're deploying into other environments, how long do you think those resources would stick around for? I don't have an answer, so you can shout it out.
It depends.
It depends? All right. So it's pretty much the answer I was expecting, really. I don't know why I asked anything else. Thank you. What I wanted to point out here was that typically over time, resources can change once they're deployed, right? So people can go into the consoles, they can make changes to tags, or your tagging policy might change that, we're going to tag with a new taxonomy now. Or someone might go through and punch a hole in a firewall, is a typical example we use. Or, you're going away on having a sale on the weekends, or you're going on holidays, and you're like, you know what, I don't want to get any phone calls on my server, I'm just going to bump up the EC2 size to be a bit bigger to make sure no one calls me. Yeah?
You mean not via Terraform?
Yeah, not via Terraform,
Not on my
right?
watch, so right?
Not on your watch?
No.
That's the right attitude, right? So what we now introduced into Terraform Cloud is this functionality called drifts. And this allows Terraform to go out every day and say, hey, what's deployed in AWS, does that match what's in my state file? And my state file is a representation of my code into AWS. And so what I've done here is I've actually deployed an instance earlier today, and then I went into the console and I updated the tags, I think. Updated my tag here on my AWS instance, and I've added a bad tag. And so Terraform Cloud has gone out and said, hey, what is actually deployed in AWS doesn't match what was written in the code. Do you want to do something about this? So someone's gone through the console or using another automation tool, AWS CLI, they've made a change, and now what your infrastructure is doesn't match what you've coded. So do you want to do something about this? Do you want Terraform to go out and rectify that to match your code? Or are we going to update our code and say, no, we need to update our code because this was deployed 6 months ago, and the way we're doing things is different. But this gives you the ability to manage your infrastructure on day one, and then run it on day 2 and 3, and so on into the future, so that your infrastructure as code is not only a representation of how you've deployed your code, but you can be assured that it's always going to match that. So now, your description of your infrastructure is your Terraform code, and make sure that you've always got that known state, which is what you're looking for, that repeatability with those modules and those infrastructure as code principles. I think that's everything, unless there are any questions. Yes?
Just one comment about where with the variables. So with a module, of course, variables are great, and a handy tip is to make sure that you set the best default values for every variable to give your modules the most utility, right? If you can run a module and you just say, tell me the name of the stack, and that's all you need to know, that's great. But then on the top level Terraform, when you're saying, this is the specific requirements for this actual application, I don't use variables, because I want the configuration to be all in the code.
Yep.
I have to see. If something changes because a variable's changed and Terraform is rerun, but the code's not changed, that's not a good place to be, because then you go, what changed? Who changed it?
Yeah, exactly right. So that's where so firstly, you're talking about a customized module, right? So this is the way you want it deployed with sensible defaults.
For modules.
Yep.
But at some point you need the code base that says this is the specific requirements with the specific details for this component of software.
Yeah, and that should be baked in.
And that one, I don't have a separate variables file, and in fact I don't even allow variables.
Yeah, no, so
I inject a standard set of variables like app name, component name, branch name. That's all you get. Region. If you can't key off that.
yeah, no, and that's absolutely when I was talking about the 3 tiers of modules, right? You can surface the information that your consumers need. You want to make it easy for them to consume, so not everyone needs to be the expert in this field, right? So if you've got a module where you say, this is what I know you guys need, you shouldn't need anything more than this, it should absolutely be baked in, and just give them enough to get going without shooting themselves in the foot. And then you can use the drift feature here, because you said if something changes, you want to know about it, right? If someone's keyed in the wrong value, we've actually got checks, precondition and post-condition checks now in later versions of Terraform. So you can put some some controls around what variables are people feeding in. If you want your prefix to be your a 7-digit employee number or username or something, we can do a check for that, and then actually give that error back to the user and say, your prefix should be your username, and you've put, first 31 digits of pi. I don't think that's your username, right? So correctly do that, yeah.
Yeah.
But that's absolutely correct.
So yeah, at that top level, I see a lot of people, creating a variables file, and then they're basically just mapping variable name to variable value, right?
Yeah.
It doesn't actually help to maintain the top level configuration. It's so much easier to read, I'm creating this, and here is the configuration for that. You can read it more like a sentence rather than go, you've got to jump between the two docs. Now in a module, of course, you don't know the values,
Yeah.
right? But at that top level, don't use variables. Just put the values, because it's so much easier to read and maintain.
Yeah, definitely. Is there another question on the back there?
Yeah, so currently we're not actually using Terraform. We're actually using CloudFormation.
No, just send the microphone up. I just can't hear you clearly, sorry.
So currently we're not actually using Terraform, we're actually using CloudFormation to set up all our resources, but we're finding it's a bit like super verbose CloudFormation to actually do this stuff. But we're actually using something similar. So we have our CloudFormation templates, and then what we do is we actually have configuration repos, which is specifically just documenting the configs that are passed to each template to deploy on the resources. And one of the reasons we do that is to keep track of changes that happens in the environment. With Terraform, is there something like that we can use in the platform to actually keep track of these changes, or would you use the same approach, having conf repos and deploying those?
So firstly, like the first place where you're starting to track your repos would be within Git, right? Which would show you who's made changes when.
Yes.
And then within Terraform, you're going to have a full audit trail of what has happened from this repo. It's mapped to a workspace. And then I've got a log of all the different runs that have been triggered over the lifetime of the workspace, showing me who has done what. So this was triggered by me through the UI. There will be some in here that have been triggered from Git hooks. So if I make a change in a commit in Git or a merge, then this will automatically trigger and update my infrastructure. It's going to show me the branch and the Git commit. So at this point in time, 3 hours ago, this change was made, and I can click on my Git commit reference and just see what was the code that was run at this time. I can also click on the run, and it will give me a full run, a breakdown of all the different resources that were created. The S3 bucket is going to give me the breakdown of that bucket within the plan, so show me what happened. This is just the plan, but in the apply, I'll have the same output each time something was created. Does that answer your question?
Yeah.
There's this guy in the yellow shirt just next to the microphone, so he's probably going to get it next.
That's very convenient. So we know it's easier to create tagging policies when you create all this infrastructure, but let's say you're trying to fix tagging across your landscape. Can you use Terraform to go through all your infrastructure and enforce and create tagging for all your resources?
I know the answer to this.
Okay.
Okay, so yeah, you can set in the Terraform configuration. In the Terraform configuration, you can set global tags to take, those common things like the whatever app naming convention you have, or component or branch names, all of those common tags, and you can set the configuration. And then anything that can have a tag, Terraform will automatically apply those tags across the board on everything.
Yeah, absolutely. So there's a global tags configuration within Terraform. So you would update your Terraform configuration in each repository that's running Terraform with the new tagging schema. The catch to your question is, if Terraform doesn't know about it, it's not going to tag it. So you need to, Terraform needs to know what infrastructure it's managing before it's going to tag it.
I have a real world hypothetical example. So there's an
Is it
enterprise.
real world or is it hypothetical?
Let's just say it's hypothetical. So there's an enterprise which uses AWS and also has on-prem infrastructure, and they're using CloudFormation, and say I kind of mention, oh, like, have you used Terraform? And someone who set up the CloudFormation says, yeah, I've used Terraform, but within this enterprise, most of the people doing DevOps have a development background, and so the training is too hard, so we're going to move from CloudFormation to CDK. And I've kind of mentioned, well, Pulumi might be a useful stopgap. So my question is, how mature is Pulumi for controlling Terraform? Can you tell us a bit about like the Pulumi Terraform integration, and also can you use Pulumi within any of these kind of cloud Terraform services?
It's a great question. So Pulumi is so everything on Terraform Cloud is not compatible with Pulumi, right? So they've got their own platform and approach to how it should be run, but it consumes the Terraform providers and the Terraform modules. Now, this has come up twice now, so with the AWS CDK that Russ mentioned earlier, Terraform actually has its own CDK built on top of the AWS one, and it's going to be pretty similar to the capability that Pulumi is offering. So in terms of a developer experience, they're going to be pretty similar with the offerings there with TypeScript and C# and Python and stuff to consume essentially the same providers and the same modules to extract that infrastructure. One of the things I'd say is it's interesting that you've said that the developers don't want to reskill onto the Terraform language, and they'd be happy to stay within whatever format that they're comfortable with, and that makes sense if you're a developer. But when you try to scale, we tend to find that with the success of tools like Ansible and Kubernetes, YAML, people are really familiar with these simpler markup type languages, and HCL lends itself to that with additional features within the language set for you can do slightly more advanced tools with the libraries built into HCL. I find that probably about 80% of the users I talk to are comfortable using HCL, and the last 20% are those kind of pure developer types who really want that flexibility to do some advanced tasks within TypeScript or Python or whatever they're using, because they're sort of coding their application and their infrastructure at the same time. But when we talk about scaling out, I see a lot of the scale customers are actually most comfortable using the markup language because it's simpler to adopt, and then those developers can just have their environment stood up and off they go. But if you do want to put them together, the CDKs are going to provide a similar experience.
Thank you guys. Good news, the pizza's here. Okay. Thank you so much, Patrick and Russell. Fantastic presentations, and I do want to thank you guys for your patience. I really did force you guys to stay in, but don't blame me, that's the pizza guys. Apparently they were stuck in traffic. But either way, thank you so much. I just have one quick shout out for AWS. Just give me 1 second. So we've got this awesome security forum which is coming up on 19th of September, and it's literally right there. That's the ICC building. It's going to be super awesome, so I'd suggest you guys to kind of scan this barcode. I'd also put this up at the end of the presentations, and you can come and ask me questions. And also our awesome Belinda, she's just right out there. You can ask her some questions as well. It's just going to be at the ICC, and do not forget to take your work laptops out, because there's some workshops, super interesting workshops that's going to take place in the afternoon. Also, I'm very, very proud to announce that Polar 7, along with AWS, we're going to be doing something different next month. Instead of all these presentations, we're going to go a bit hands-on. It's an opportunity for you guys to get your dev hats on and kind of come and do this serverless stuff on-prem, literally with us. And Polar 7 and AWS will be hosting you guys, helping you guys out with my team at Polar 7 will be coming up and helping you guys to kind of play around with some of the tools. All the details are available in the MeetUp page as well. It's going to be super easy for you guys to kind of figure that out, but we'll be sending a few comms out to you guys so that it's more easier. But it's going to be at hands-on focus, the next 2 ones. So please do come up, enjoy these sessions. And again, I appreciate patience that you guys have shown. Thank you so much. The pizzas are ready for you guys. Enjoy the drinks. And if you've got any questions for the speakers, please come, ask them, and we will go from there. And I'll see you guys next month, I guess. Cheers. Thank you.